So now that we've done all this stuff on partial derivatives, what is it good for? So the reason we're doing this is it's a method for testing if an ordinary differential equation is an exact equation. So the way it kind of works out, I've got this diagram here. So you start with your function f of x comma y equals some constant c, and then you can create this other function, the derivative with respect to x of f of x comma y. You take the partial derivative of the function f with respect to x, that's the first piece, and then you take the partial derivative of f with respect to y, that's the second piece. Oops. Okay, and then because whenever it doesn't matter what order you take the partial derivatives in, you should get the same answer. So if I take this partial x and I apply partial y, partial y, then that's partial squared f. The x is on the right because that was the first partial derivative we took. The y is on the left because that's the second. And then if I take, the partial f partial y, and I take the partial derivative with respect to x, then I get partial squared f partial x partial y because x was second and y was first. And because f exists, these are going to be equal. But, does f exist? That's the question. So normally, right, you're not given the function f, you're just given the difference equation in the middle. And so typically there's a name for these parts of the function. So normally you have this m of x comma y plus n of x comma y prime equals 0. And it's very difficult to distinguish between the letter m and the letter n. So what I normally do is I'm going to use m is going to be Mars. So I'll say Mars for m. And I'll say Neptune, the planet, for the letter n. All right, so this is Mars of x comma y plus Neptune of x comma y prime equals 0. So a test that you can perform if you want to know if f exists is, this is really partial f partial x if it exists. So I want to test. My test is I want to do partial Mars partial y, right from the bottom of my diamond there. Right, there's my partial y. And if I have Neptune partial x, not a great diamond, then those should be equal. And the question is, are they? So if partial m partial y equals partial Mars partial y equals partial Neptune partial x, then exact. Meaning that this function f exists. But in the other case, if partial m partial y does not equal partial Neptune partial x, then not exact. All right. And so if it's exact, you should be able to find f, and you essentially kind of work your way backwards. So you can kind of go up this thing and do some integrals. And we'll go over that in the next video.